All right, so obviously from this section, you have to know your sum and difference formulas, okay? So if I'm going to do 195, I got to figure out what sum or difference gives me that, which is what works, because there's more than one.
150 and 45.
6, okay, 150 and 45, that works. 135, wait, say again.
195.
45 and 150, right? Yeah.
Oh, yeah.
Yeah. Maya, what did you say? 135 and 60, that works. Did anybody get one that wasn't a fraction within a fraction? Like you got like the root 3 in the top and the 1? Oh, so we got lucky. I think we did a difference in my first class that got it. Okay, so let's do 135 plus 60. Okay, so we're going to do first the sign, and the pattern for sign is what? And now that my 7-year-old knows it, I totally think you guys should have to know it, FYI. He could probably tell you the pattern. He practiced it so many times. Okay, it's sine, cosine, cosine, sine, right? So sine of 135, cosine of 60. And I keep the positive, negative sign the same. So it's positive cosine 135, sine 60. And then you will have your unit circle, okay? Not yours. I gave you like just a copied little guy in the corner because I didn't keep all of them after the last test. So 60 degrees is your 1/2 and root 3 over 2. And 135 is your negative root 2 over 2. Root 2 over 2. So sine at 135 is root 2 over 2. Cosine at 60 is 1/2. Cosine at 135 is negative root 2 over 2. And sine of 60 is root 3 over 2. And then I want to multiply it out. They both have a denominator of 4. So I'd get root 2 minus root 6 over 4. So had you picked different numbers, you may have gotten root 6 minus, or negative root 6 plus root 2 over 4. That's fine. That's still the same combination. So this would be sine. Order doesn't matter as long as the signs are right. So as long as you didn't like have a negative root 2 and a positive root 6, you're fine.
I left it we had before that.
So you got to go to the next step. Like you won't lose all your credit, but you can simplify. That is not simplified. So you want to make sure you combine it into one fraction. Yeah.
So like it doesn't matter if I put like the actually never mind, I answer wrong.
If it was negative root 6 plus root 2, that's how else I could look. Over 4, that's fine.
Okay.
Yeah. Okay, so then we're going to do cosine. So cosine's pattern is what? Cosine, cosine, sine, sine. And this time, you switch the sign. So if it's plus, it's minus. So the cosine at 135 is negative root 2 over 2. Oh, yes, I did. Thank you. Cosine here, 160, 1/2, and then root 2 over 2, and sine at 60, root 3 over 2. Nope. Order doesn't matter as long as they both have a negative. Okay, and then we get into the tangents. So my advice is when you do get your test, on the right, on the top like right corner is where I put your unit circle. Add a little note in there like all of your over 3s are root 3s for tangent. All of your over 4s are 1, and all of your over 6s are root 3 over 3. Just remember to apply the signs. So like all students take calculus as you go around. Tangent's going to be positive in the first quadrant, negative in the second quadrant, positive in the third quadrant, negative in the fourth quadrant. So from here, when I do tangent, I'd get tangent of 135. The sign in the top matches, so it's plus. Over the sign in the bottom is the opposite. So if it's 135, that's one of your over 4s. So I said to not forget the sign, and then I forgot it. I was just trying to teach you a lesson. 135 was negative 1 plus root 3 over 1 minus negative 1 plus, or times root 3. So I get negative 1 plus root 3 over 1 plus root 3, and then we rationalize. So on the top, I get -1 plus root 3 plus root 3 minus 3, or -4 plus 2 root 3. And then the bottom, okay, bottom is a squared minus b squared, which would be 1 minus 3, -2. And then this is 1, so I'll actually make it a +1. So this becomes a +2, and this becomes a -1. 2 minus root 3. Better? Yeah. Questions on tangent or sine, cosine, or tangent, because you have to do each of them. So you're not going to get like all 3 in 1 for your test. It'll say like find the sine or find the tangent or find the cotangent or find the cosine. Okay. It's not going to give you the breakdown of the angle. You have to figure it out. Which ones would add up to be whatever it is. Okay. It does give you a breakdown and then doesn't. So just make sure you know how to do both. Mauricio.
So do we have to put like for cosine and sine, you put like cosine next to
Oh, I just was labeling them. So this is the tangent. I was just showing you what they are. You don't have to write that. It's just if you wanted to label your answers, just realize that that's the tangent one, that's cosine, and that's sine.
Okay.
That's all. Yeah.
I was kind of confused on like why for the ones where it just gives you the angle and you have to break it down yourself.
Yeah.
Why wouldn't any like number work that would add up to that number?
It does.
Okay.
It's just there's a fixed amount that can work. So the combinations will always be the same. It's just maybe the order that changes. So like if you had picked another combination for cosine, let's say, you might get -√6 minus √2 over 4.
Okay.
The order just might be different, but the number combinations are still going to be the same.
Okay, so
Because you're trying to figure out what two angles
Yeah.
either add up or the difference, but those two angles have to be on your unit circle. So there's a limited amount of angles you can use.
okay.
Otherwise, you can't go any further.
Is there like any like specific suggestion that you have? Like
I mean, the easiest thing is if it ends in a 5, I know it involves a 45, I start there.
Okay.
And then the rest of them, you can kind of just like try, okay, if I subtract 30, is that something that's still on my unit circle? If I subtract 60, is that something that's on my unit circle?
Okay.
Are we gonna get a negative one, like on the homework?
No, I didn't put a negative.
Oh, okay.
Any other questions before the last two? Okay, so then the last two are working in the opposite direction. So it's already expanded. You have to figure out what's the pattern, and then if it's the pattern in which it's sine, you keep it as positive. If it was cosine, you change it so that it's different. And then obviously if it's tangent, you want to match it with the sign in the top. So it says find the exact value of the expression, which means combine it and then also figure it out. So because that pattern is sine, cosine, cosine, sine, I know it's sine, and positive or negative stays true with sine, which means that minus is going to stay. So this is 120 minus 60. So I'd get the sine of 60, and we know the sine of 60 is √3 over 2. And then the bottom, obviously, it's tangent, and tangent, you match the sign with the one in the top. So this would be tangent of 25 plus 110, which is the tangent of 135, which we already found was -1. Question on either of those. So those are actually, in my opinion, just a lot easier, unless you get stumped and you don't know what it is.
Are we gonna have it on the test?
Something like that. Mm-hmm. What?
So what do you do with the bottom? Nothing?
What do you mean with so the bottom just tells you what kind of pattern it is. It's a tangent plus a tangent over a 1 minus the right? So that tells you it's tangent. And then with tangent, you keep the sign with the one on the top. So if I had worked backwards, I'd get back to where that is. But this is working the other way around.
What if you like found like the sign of 120 on the circle and out of all those, would that come out?
Yeah, so if you actually found sine 120 and cosine of 60 and then cosine of 120 and sine of 60, it would have actually simplified to be the same thing.
So like for the other problems where we find out what adds up to the angle, we could.
Like, let's just say it was an angle that was already on my unit circle. Let's say I said 120, right? And I said find the sine of 120. You can either go to your unit circle and find the sine of 120, or you can use the sum and difference on 60 and 60, or 90 and 30. And it will give you the same answer. Well, I'm not going to let it be something that can be simplified. That's the difference. Yeah. So it won't be something that if you don't do that pattern, it wouldn't be on your unit circle. It'd be something like 3 where 25 and 110 are not on your unit circle, so it can't be done that way. Alex.
So for those, since we know that formula is for sine, right? For number 2.
Yep.
So because it's the sine formula,
You keep the positive negative sign as it is, and then you're finding the sine of what you get by doing 120 minus 60.
Okay, so you don't worry about the cosine.
No, the cosine part of that just tells you what the pattern is.
Okay. And then for tangent, what do you say again? Like, you just don't worry about the...
What's there is the expanded form of the difference or sum of tangent. And with tangent, we keep the two, obviously we take the two angles, and we match it to the sign in the top. So because the top is addition, I know I'm supposed to take that 25 and add it to 110. Mauricio.
So that 1 minus on the bottom is just there to show you that it's a plus on top.
And that it is tangent, right? Tangent itself, sum and difference, is tangent of the first and tangent of the second over 1 minus or plus tangent of the first times tangent of the second. I'm sorry?
Even if it's plus on top of it, or if it's minus on
They're always opposite. So if it's plus on top, it's minus on the bottom. And if it's minus on top, it's plus on the bottom. And you match it to the top.
I'm gonna say like for number one, like I find two angles that add up to 185, and then I do sine and cosine fine, and then I find that tangent is hard to solve it.
You just say a little prayer right before you get to that question that you don't have tangent.
No, I was gonna say like.
You can take the sine over the cosine. Is that what you mean?
Yeah, like I was gonna like say.
You're not going to have all three, though. That's the catch.
But we're not gonna have all three to do.
Right. So could you do it that way? Sure, you could work through finding the sine of that angle and then the cosine of that angle and then doing sine over cosine. But you're not going to have all three. So you'd be doing extra work.
Would you get full credit even if you did that?
Sure. Yep.
What do you mean we're not gonna have all three?
Like it won't say find the sine, the cosine, and the tangent of 195.
Oh,
It will
you-
just say find the sine of 195 or
So
find the
we could use
cosine.
information from the other parts to answer.
Right, you could do it the long way around. It's just you're doing extra work you don't need to do.
So you look at the windows on the test.
Well, one just like that, and then there's one with the expanded ones. Yeah.
For number one, it's like 195.
Yep.
What do you do when it's negative?
So it's the same thing. You would be trying to find two angles that sum to whatever that is, and most likely it's going to be a difference. It's just, but I didn't give you a negative.
But do you make it so like that they add up negatively, like?
So like actual sum. So like let's say it's negative 100, right? You could do negative. Let me think. 180. No, 180 is not on there. Negative 110. Plus, let's just say it's not going to be a unit circle, but plus 10, right? So that the actual sum of this gives you that. Or I could do negative 60 plus negative 30. And those are both, nope, negative 40. And it would add to that.
Can you also do it the negative one? You make it positive, like you add 360 to it, and then do it from there.
Like a coterminal one?
Yeah.
Sure. Yeah, it's the same angle. Any kind of coterminal is the same measure. But I didn't put negative on your test.
Make it like 260 and then do that.
Yeah. 12.
And the cosine of b is equal to negative 3/5. They're both.
The cosine of V?
Yes.
Negative 3/5. Okay, so and they're both in the third quadrant, right? Yeah. All right, so this is the information we got so far. Just the sine, so opposite over hypotenuse, and then the cosine, so adjacent over hypotenuse. The fact that they're in the third quadrant tells you that both the x and the y would be negative, right? Which means that missing side on my u is a negative 15, because 8, 15, 17 is a triple. Third quadrant means back and down. And then u, or v, my other triple is 3, 4, 5, and that means that this is also a negative because you'd be moving left and down. So then I want to break apart my tangent of u plus v in its sum and difference formula, which is the tangent of the first one. Keep the sign the same, so it'd be plus. Tangent of the second one over 1, and you change the sign in the bottom, minus tangent of the first times tangent of the second. And then just plug them in. So the tangent of u is the opposite over hypotenuse from this triangle. Opposite over adjacent. So it would be negative 8 over negative 15 plus the tangent of v. So now I'm using this triangle, which is negative 4 over negative 3 over 1 minus the tangent of u, which is negative 8 over negative 15 times the tangent of v, which is negative 4 over negative 3. So this becomes positive and positive. I got to find a like denominator there.
If all the negatives cancel out, why do you?
I just wrote it out. They will eventually cancel out, yeah. So then this I would have to multiply by 5 and by 5 here. So I'd end up with 8/15 plus 20/15, which is 28/15, and that's my numerator. And then the denominator, 1 minus, this will be positive and this will be positive. That's 32 over 45. So this would be 45 over 45. 45 minus 32. 13 over 45. And then that's my denominator. And then I do keep change flip. So 28 over 15 times 45 over 13. And then this goes in 3 times 28 times 3. 84 over 13. So you got to use your triangles to figure out the missing side, and then from there use your sum and difference formulas and simplify as best you can. Biggest mistake made I've seen like on this and previous tests is that they take the bottom and they add those two fractions. It's the sum or the difference in the top and then 1 minus the product, or 1 plus the product in the bottom. Just be really careful. And again, know your triples. It's going to save you a ton of time. Any other question from either homework assignment? Yeah.
What was the answer to 84?
Okay, so on the review assignment and in the module is a note that looks like yours isn't pink, yours is just white. Okay, but it is a note that's going to take you through basically all the information you need to know. I put on the assignment like my version of the notes filled in and then the non-filled in, but we'll get through as much of it as we can. So for 5.1 and 5.2, I just did a verifying one, and then you'll see it again with the solving of the problems and the sum and difference. But you're only going to really see just one, and it's not simplify, it's verify. So you got to know all this stuff, right? Like that the secant is the same thing as 1 over cosine. That cosecant is 1 over sine. That tangent is sine over cosine. Cotangent is cosine over sine. And also 1 over tangent. So obviously all the reciprocal functions you need to know. And then the cofunctions. So if you see pi over 2 minus an angle, you got to know that you replace it with its cofunction. And sine goes with cosine. Secant goes with cosecant. And tangent goes with cotangent. And then all of these are interchanged with the one on the right. So if I saw the cosine of pi over 2 minus x, it's the same thing as sine. The cosecant of pi over 2 minus x is the same thing as secant. And I'll post a Quizlet that goes through those if it helps you, the flashcards of all the reference stuff on this. Your even and odd identities, remember that sign, cosecant, tangent, and cotangent. If the angle is negative, it's the same thing as making the function negative. So this would be negative cosecant of x, negative sine, negative tangent of x, negative cotangent of x. The two that are not, those are even, are cosine and secant. So this is the same thing as saying just cosine of x, and this is the same thing as saying secant of x. So the ones on the left, the negative gets bumped out to the front. The ones on the right, it does not. And then your Pythagorean identities. So what's the first one? Good. And then if I divide each of those by cosine, I get cosine squared. Tangent of x plus 1 equals secant of squared of x. And if I took the original ones and divide them both by sine, I'd get 1 plus cosecant squared of, cotangent squared of x equals cosecant squared of x. And then obviously your unit circle is going to come in handy. That'll be on your test. So this is the basis of what you need to know for 5.1 and 5.2. There's lots of practice problems on the review for you to do. You had some from last week, right? Like on Thursday when I posted that review for 5.1 to 5.3.
How many questions?
There's 12 questions. Yeah.
An answer key up for the classwork that
we did.
I can post them. Okay, then a couple of just verifying trig identity questions. Okay, if you saw something like this, 1 plus tangent squared times cosine equals secant theta, where would you start? Okay, which is what? Secant squared. And then secant squared becomes? Good. And then you can cancel one of the cosines, so you end up with 1 over cosine, which is secant. The biggest piece of advice I could give you on the 5-2 verifying is that you make sure you show all your work. You cannot skip to the bottom and get credit for that problem. Say that again. Yeah, you could do that different ways. How about this one? Cosine to the 3rd theta plus sine squared theta times cosine theta equals cosine. What's one way you could do it? You can factor out the cosine. I heard something else though. So you bumped it to the left side, okay? You could also divide cosine straight across, right? All the way across. So there's a couple different ways to do it. So I think that more of you said factor out the cosine. So let's do that cosine, and then it would be cosine squared theta plus sine squared theta equals cosine. And then what? Yep, cosine squared times, or plus sine squared is 1. And then this would be cosine equals cosine.
If we were to, like, on the test, move the cosine that was, like, outside.
All right, so sine of x plus 1 over cosine. Again, what's like one way we could start this? Because I've already seen it done twice today, different ways. Nora. Split the fraction, so you get sine of x over cosine plus 1 over cosine. And then sine over cosine is tangent. And 1 over cosine is secant. So these should not be hard. I also saw the other way worked. Like on the right hand side, they put tangent as sine over cosine, secant as 1 over cosine, then combine them into one fraction. Same thing. All right, so 5-3 is where you started with your solving of the trig functions. So the biggest piece of advice I could give you is if you had a unit circle and it looks pretty much similar to what's there, I would again add like some sort of a note on the bottom or next to it or somewhere, make your life a little bit easier. All of your over 3s for tangent are root 3. All of your over 4s for tangent are 1s. And all of your over 6s for tangent are root 3 over 3. And then all you have to do is worry about the sign, right? All students take calculus. So that if it's in your 3rd quadrant, it's positive. If it's in the 1st quadrant for tangent, it's positive, and then everywhere else will be negative. The other thing I would add on is your restriction for tangent. So tangent is negative pi over 2 to positive pi over 2. And then the other thing you should really pay attention to is the directions. Do your directions give you an interval restriction or not? So if you look at this when it says find the solutions for each equation, does it tell you to restrict it from 0 to 2 pi?
No.
Which means what am I doing with my answers here? What do you have to do if it doesn't restrict it? You put plus 2 pi k. Pi 2k doesn't matter. The order doesn't matter. For tangent, and for sine and cosine, and for tangent, pi k. Okay? So you have to know to restrict it yourself for tangent, and then you also have to know how to add on the interval after that. So for this one, I would solve it first. So I would add the 3, cosine squared x equals 3, divide by 4, and then square root it. plus and minus the square root of 3 over the square root of 4, which is 2. So I'm looking for everywhere on my unit circle, because it's cosine. The x is positive or negative root 3 over 2. So I know this happens at all my over 6's. So this is a pi over 6, a 5 pi over 6, 7 pi over 6, and 11 pi over 6. And because this is cosine, to each of these, I add 2 pi k. If you don't pay attention to the instructions, you're going to lose partial credit on those. Don't do it, okay? If you want to go through like all the ones that say solve and figure out which one of them has the 0 to 2 pi and like circle it, make a note of it, whatever you need to do to make sure that you know that you're doing that, then that's fine. Just make sure you're doing it.
What would the answers be if it's if it has a restriction?
If it said it would be all of those without the 2 pi k's. So if it said give me all the answers from 0 to 2 pi, then it's pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. You just don't add on the 2k pi's.
So for this one, it's because it's plus minus that you list all of them.
Correct. If it was just a positive root 3 over 2, then I'm only looking first quadrant and fourth quadrant because that's where cosine would be positive. Okay, so 3 tangent plus 2 equals tangent of x, and this is under the same set of instructions. So solve it, and again, there's no restriction on that interval except that it is tangent now, so you have to know to look negative pi over 2 to positive pi over 2. So I can move so that both tangents are on the same side. And I'd get 2 equals negative 2 tangent of x. And then divide both sides by 2, or negative 2. And I get negative 1 equals tangent of x. So because I'm only looking first quadrant and fourth quadrant, I know if it's negative, it's got to be the fourth quadrant, and my domain is restricted to negative pi over 2 to positive pi over 2, which means negative pi over 4. And to tangent, we add pi k.
Are we always going to get our answers in radians?
Yeah, so I didn't put anything restricting in the degrees. I kept it in radians.
So for tangent, you want to use the first and fourth quadrant.
Correct. And not even your natural fourth quadrant, but the negative pi over 2.
And then sine, cosine.
The whole circle. All right, now the directions change. So it says here on the interval 0 to 2 pi. Now I know I don't have to add on the 2 pi k or the pi k. I don't have to restrict it for tangent. But this is one of the multiple angle ones, and it says it in the instructions, but if it doesn't, you have to catch it because there's something being multiplied by your x this time. So I would try to find where sine on my unit circle is 1/2, which is going to happen at pi over 6 and at 5 pi over 6. But instead of, and I would normally have like 2 plus pi, 2 pi k, okay, if this wasn't here. But it's not there, which means it's literally pi over 6 and 5 pi over 6 equals 2x. And then I would divide both sides by 2 or multiply by 1/2. So if it didn't say 0 to 2 pi, then I would have had to take 2x and set it equal to pi over 6 plus 2 pi k, and 2x and set it equal to 5 pi over 6 plus 2 pi k. So when I divide by 2, I have to divide both of those by 2. And I end up with pi over 12 plus pi k and 5 pi over 12 plus pi k. So this is if it didn't say the interval, and the first one is if it does. Okay, the next thing, the directions actually say the following exercises involve trig functions in quadratic form. Solve each on the interval of 0 to 2 pi. So first thing you identify from there is that it's on the interval, which means no adding 2 pi k. The second thing is it says quadratic, which really just means that there's a squared in there. So it's kind of an indication you're either going to do the even root property or factor. So I can solve this for the sine. And then square root it. I just have to make sure that I do plus and minus the square root. So this would be plus and minus 1 over 2. So I'm looking for everywhere on my unit circle sine is positive or negative 1/2, which is going to happen at all the over 6s. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. The other way you can do this is actually by factoring it. So this is the different 2 squares. 2 sine of x plus 1, 2 sine of x minus 1, and then I can set them each equal to 0 and solve. So I'd get x equals negative 1/2 or sine of x, sorry. And sine of x equals positive 1/2. So same 4 angles, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, then it says this one uses an identity to solve each equation. So the identity means those Pythagorean identities, right? So if I look at 2 sine squared of x plus cosine of x minus 1, I can't replace the cosine because it's not squared, which means I have to replace the sine. And since sine squared plus cosine squared equals 1, sine squared would equal 1 minus cosine squared. So 2 times 1 minus cosine squared plus cosine minus 1, distribute the 2. And then as soon as you see the squared and the non-squared, hopefully that's your cue. You're going to be factoring these out. So I'm going to combine the 2 and the negative 1, positive 1. Okay, so then I would multiply everything by negative 1 so that my first term is positive. And then factor. So 2 cosine x and cosine x. And then I'm looking for the factors that when multiplied on the outside and the inside give me that negative 1 in the middle. So negative 1 and positive 1. Outer negative 2 cosine. Inner positive cosine. That's where my negative 1 comes from. So then I set them each equal to 0 and solve. So I get 2 cosine of x equals negative 1, cosine of x equals negative 1/2, and cosine of x equals positive 1. And again, this time there is no interval, which means I have to figure out where it is on the unit circle and add 2 pi k to it. So cosine would be negative 1/2 at 2 pi over 3 and at 4 pi over 3. And then I would add 2 pi k. And then cosine's also positive 1 at 0. And again, add 2 pi k. All right, then we get into 5 for the sum and difference formulas. So remember that sine would be, the pattern is sine, cosine, cosine, sine. So sine of the first, cosine of the second. Keep your positive, negative sign the same. Cosine of the first, sine of the second. This would be sine and cosine with a minus between them. And then cosine is cosine, cosine, sine, sine. So cosine, cosine. And this time you change the positive or negative sign. And so if it was negative, it would be positive in between. And then tangent, you would match the sign in the top, so it's a sum. 1 minus tangent. And here, tangent of u minus tangent of v. Over 1, change your sign, plus tangent of u, tangent of v. So something like sine of 105. Again, I see a 5, so I'd always try to subtract the 45, and that's 60. So I can do 60 plus 45. So it would be sine of 60, cosine of 45, plus cosine of 60, sine of 45. Sine at 60 degrees is root 3 over 2. Cosine at 45 is root 2 over 2. Cosine at 60 degrees is 1/2. And sine at 45 is root 2 over 2. So I'd get root 6 over 4 plus root 2 over 4. And then I can combine that into one fraction. The next next question says, write each expression as the sine, cosine, or tangent of an angle, then find the exact value. So these are already expanded. You want to condense these. Cosine, cosine, sine, sine is the pattern of cosine. And with cosine, we always change the sign in the middle. So this would be 70 minus 10. So the cosine of 60, which we just used up there, is 1/2. Okay, this one says verify each identity using the sum in different identities. So this is a difference for cosine. Cosine of pi over 2, cosine of x. Change your sign so it's positive. Sine of pi over 2, sine of x. And you're showing that this equals sine of x. So we know our pi over 2 is at the top. Angle here, which is 0, 1. The cosine there would be 0. The sine would be 1. This is 0. This is sine of x. So sine of x equals sine of x. So we used our sum and difference to prove or to verify. Then we got into our triangle question. So this says find the exact value of the following under the conditions. Sine of alpha is 7 over 25, and alpha is in quadrant 2. Sine of theta is 3 over 5, and theta is in quadrant 1. So we want to set up our triangles first. One with alpha, one with theta. Sine would be 7 over 25, opposite over hypotenuse. Sine here, 3 over 5, again, opposite over hypotenuse. So the missing length here is 24, and here's 4. Those are both triples. But this first one is in the second quadrant, which means that 24 is going to be negative. And then I want to separate this out. So cosine of alpha, cosine of theta, minus sine of alpha, sine of theta. So cosine of alpha is negative 24 over 25. Cosine of theta is 4 over 5. Minus sine of alpha, which is 7 over 25. And sine of theta, which is 3 over 5. And multiply that out. So it's negative 96 over 125 minus 21 over 125. And I get 117 over 125, and it's negative. All right, and then this actually 5 is on your quiz and not on your test. So that's where the notes for this test end. Good luck studying.